You are a captain of the sky, and you spot your nemesis on the horizon. Your opportunity for reward draws near. Set your thrusters full speed, prepare your grapple cannon, and ensure that your prey cannot escape. When they're in range, it's time to destroy. Welcome to the first devlog. My goal is to create a survival game, one in which you control an airship, which you can build and fight with in the sky. Let me show you what I've worked on so far. First things first is to create a ship that actually moves. So in Unreal, when you create an actor that has multiple parts to it, like I plan on having with my ship and multiple pieces to the ship, only the first item in that ship checks for collision when it attempts to move. The solution that I found was to move each part individually and then check if any of them collide. If one of them collides, take the shortest distance to that collision, and that's as far as you can move the object. The solution works relatively well. You also just have to make sure to ignore all the other parts on your ship, as well as maybe the units on the ship as well. You don't want them to not be able to move up with something standing on top of it. Now that we have a ship that can move and collide with the world, we want to make sure that the player actually can walk on this ship. So if I just leave this player on this platform, the platform's going to start moving, and if I jump on it, the character starts to get some of the velocity from the ship while it's moving, and will launch the character. My first thought to handle this was just simply attach the character to the platform, but they start to slide. I think it's something related to the character's movement system, compensating for the moving platform the same way that it kind of worked before, but now we're additionally moving it with the platform. After that, I spent a lot of time trying to figure out how to compensate for that movement. It didn't seem worth it. I found a better solution that does exactly what I want there. So my solution was to actually use a different physics scene. So every time an actor gets added to the ship, it has a separate non-moving collision mesh that we move over to a second physics scene. So what will then happen is when the player lands on the ship, they will actually have a copy of their physics moved over here. So this is where all your movement logic will go. And when the player moves around on this platform, the other one, the one that's in the moving ship, will update accordingly. So all the render happens on the moving ship, but all the collisions for the player's movement specifically happen on the non-moving ship. So when the player wants to leave a ship, though, you have to realign the characters so they'll jump off. And then after a certain point, they need to be added back together and treated as a singular unit, and they're in the normal physics world. So I have an example of that here. So I'm on this ship, it's moving, I'm moving with it. I can hop off and I quit moving with it. But on it, yep, here's that separate physics plane where you just see the ship without any of the movement. The downsides of this kind of solution, though, is you have to. There's some cognitive complexity of trying to figure out where am I, what objects in what scene, and then you have to do some transforms. But as long as you're not doing the transforms every frame, it's relatively quick. As I was preparing for this video, though, I attempted to make a cosmetically appealing ship. I found out that there is a certain number of actors when you're testing for collision that does not. It starts to lag. It starts to lag a lot. You can see here, I'm getting 10 frames a second. Now this is in the worst possible case scenario because I'm in the editor, I'm filming, it's not normally this bad, it's usually 40 or so. Still, it was at 120 before when I had only 10 parts, and this is a couple hundred. After I did some profiling, I figured out that these two functions right here were pretty much the bulk of my lag. For each object on the ship, it kind of checks that collision and then moves back to see how far can I actually move. And this other expensive function is literally just moving all the ship parts at once. So basically, what I've done just scales so poorly with the amount of actors that I'm using. Like I said, I only use about 200, and I was considering that a small ship. I was hoping to go for 10,000, something like that. So I have a few options moving forward. What is the underlying issue? As you add more parts, the amount of times you have to check for movement scales. So to fix this, I have 3 potential solutions. My first solution is just to have bigger blocks. So as a player builds, they spend less blocks to overall build, which means less collision checks. The second solution is to simplify my building placement model. So what I have is, for each block that you place, the green dot is the center of the block, so you can have a single cube, and you can additionally have a face on each side of the cube. Think of walls or floors. And then if I just move it to a singular cube model, I get rid of every face, which means 7 potential less items I have to move for each block. And the third solution is to only move the blocks on the outside of the ship and not the ones on the inside. So here, if we had a ship in 2D and we only moved the red dot ones, and we don't really need to check for the collision of this one because all the red dots around it will handle all the potential collision checks that one could have. That's a kind of complicated solution because I have to figure out how to do this in 3D and figure out where the player intends to have an interior and an exterior. It ends up being challenging. The solution that I end up going with is all of them and a little bit extra. I'm going to change how my placement system works completely, and I think this will have way better scaling in the long run. So what I'm going to start doing now is I have an exterior of my ship, so this is like, think of it more like a building than just a part. So this is the whole of the ship, and there's a separate interior, so that's going to be our additional physics plane. So the exterior will be comprised of like larger modules. These are like whole pieces, but in this example, let's just think of them as rooms in a house. The interior will have a bunch of smaller objects that the player can interact with, but these don't move on the bigger physics scene, so we don't have to worry about every time that the ship moves, we have to move hundreds of little objects. So this new solution comes with its own set of problems. Previously, when the player walked on the walk collision in the separate physics space, none of that really needed to be rendered, right? And if it was, it would be identical to what's on the ship, it's just non-physical, right? But now in this new solution, all the objects that are in the interior are in one space, and all the objects that are in the exterior are in the opposite space. This isn't a huge problem if the player can never see an interior from an exterior or vice versa. But if you have windows, doors, open faces, you need to render both at once. So I do have a solution for this problem though, right? So right now we're in a ship interior. I can place objects in the interior, and if we look out, we see another ship in the sky. We see the world and how we're doing this. Well, I'm using green screens to re-render the real world on top of what the player sees from the perspective of the interior. You can't exactly tell here, that they are two separate images that are being put together. The solution comes with two new problems though that are worth dealing with. They don't have too bad of scaling issues. The first one being that if you have a light or something outside the ship, you just kind of have to re-render that in the opposite view so that way the reflections and stuff are good. Additionally, if you want to move objects inside and outside, so right here I'm going to shoot this gun. It looks like the bullet actually went outside the ship. It's still in the interior and it just went to the end of the green screen. So translating objects is kind of like how Portal works. You just have to find out where it leaves the ship. So maybe make a portal window here and then attach it, replace it on the other side once you're done. Like I said, about a month and a half ago, when I started rough drafting this video, I found all those scaling issues after building this really complex building system, trying to fix it, trying to see what I could do there to make it run fast. And I had to gut that. And it does kind of suck, but I am happy with this new system. I think it's going to scale so much better since so much less parts are moving. And I'm kind of excited to see where this goes from here. Separate physics scenes are really cool tools. Unreal Engine doesn't provide anything like this by default. The character's movement is really not designed to walk on moving objects. And there's a lot of cool scenes that could exist if you can implement this technique. Imagine if you're in a spaceship and you're doing barrel rolls, but your character can still walk around on the ship. Or if you're fighting on a train and jumping between different trains, which are moving at different speeds. There's lots of cool things that you can do if you can implement that sort of scene. Most of the scaling issues I had actually came from my building system, just being a little complex and ambitious, instead of really the separate physics scene. But now that I can just place stuff inside my ship and it never is affected by movement, everything inside the ship is really static. I'm really excited to see how I can scale this, what kind of cool big ships I can build in the future once I make new parts that work with my new building system. And that's it for Devlog 1. I left the implementation details a little non-specific so that way Unity users and Godot users and custom game engine people can also implement something similar. It's more about the core idea versus how my specific code works, because I have my own quirks to handle my building systems and stuff. But if you have questions about how to implement something like this or want more details, either leave a comment, or I have a Discord and a Twitch where you can ask me there. I'm going to start working on new features and figure out what my next devlog is going to be. Peace.